In this video, we'll understand about Euler and Hamilton paths. What is Eulerian path? It is a path in a graph that visits every edge exactly once with or without repeating the vertices. Consider this example. It has got A, B, C, D, 4 vertices, and then E1, E2, E3, E4, E5. There are 5 edges. So if we start from B and we move on to A, we move on to B, and then we again move to D, then C, then B, we may notice that we crossed all the edges, visits every edges, but there are some repeat of vertices. But still, we are able to visit all the edges only once. So we call this particular graph as a Euler path. Again, this is also an Euler path. We may notice A, B, C, D, 4, E and F is also there. So there are 6 vertices and then 8 edges are there, E1, E2, E3, E4, E5, E6, E7, E8. Again, in this, if we starting from B, if we move on, B to A to D, then D to E, E to B, then B to F, and then F to D, and then D to C, then C to B. We could visit all the edges, but there are some repeat of vertices also, right? Eulerian circuit, it is an Eulerian path which starts and ends on the same vertex. The second example is an Eulerian circuit also, because it starts from vertex B and ends at vertex B. So we can consider this example as an Euler circuit also. Euler graph already we saw. We are just going to go through once again the definition. A connected graph is called as a Euler graph if and only if all its vertices are of even degree. Right. Next, Hamilton path. If there exists a path in the connected graph that visits every vertex exactly once without repeating the edges, then such a path is called a Hamiltonian path. Then we'll understand what is Hamiltonian circuit. If there exists a path in the connected graph that visits every vertex exactly once, except starting vertex, without repeating the edges and returns to the starting vertex, then such a path is called as a Hamiltonian circuit. Then Hamiltonian graph already we had seen previously, but once again we'll read the definition. Any connected graph that contains a Hamiltonian circuit is called a Hamiltonian graph. Note, in Hamiltonian, all the edges may or may not be covered, but edges must not repeat. Any Hamiltonian circuit can be converted to a Hamiltonian path by removing one of its edges. There may exist more than one Hamiltonian paths and Hamiltonian circuits in a graph. And then Dirac's theorem, what is that? If capital G is a simple graph with n vertices, where n is greater than or equal to 3, more than or equal to 3 vertices, such that the degree of each vertex in capital G is at least n by 2, then capital G has a Hamiltonian circuit. Then comes Or's theorem. If capital G is a simple graph with n vertices, with n greater than or equal to 3, such that degree of U and degree of V greater than or equal to n for all pairs of non-adjacent vertices U and V in capital G, then G has a Hamilton circuit. Let us understand some example of this Hamiltonian path. Here this graph A, B, C, D and E, there are 5 vertices, and Hamiltonian path, if we start from A to B, B to C, and C to D, and then D to E. Hamiltonian circuit, here it is E to D, D to A, then A to B, B to C, and then ending with E. That is Hamiltonian circuit also, Hamiltonian path also. Whereas this one, it is only a Hamiltonian path, but you can't make a circuit out of it. So let us start from E to A to B, B to C, C to D. So here circuit is not possible. Then let us understand what do we mean by Eulerian digraph. It is a connected digraph where digraph means directed graph, where every vertex has in degree equal to its out degree. So let us understand this in an example. So this is an Eulerian digraph. So in degree for C is 1, only 1 is coming, and out degree for C is also 1 only, 1 is only going out from C arrow, and then for D 1 incoming, 1 outgoing. For B 1 outgoing, here another outgoing, that means 2 out degree, in degree, here 1 and then here 1. For example, A also, 1 is coming like this, 1 is going like this each. So we may notice that it is out degree and in degree are equal for each vertex. Hamiltonian digraph. It is a connected digraph that contains a cycle which includes all the vertices. So A to B, B to C, C to D, and D to B also, D to A. Here ABCDA, ABCDA forms a cycle and it includes all the vertices. So we can call this as Hamiltonian digraph.